These are high voltage transmission lines. They form an interconnected network across the United States to supply electricity to people like you and me. The network, or the grid as it's commonly called, takes power from generation plants like nuclear reactors and distributes it across its vast network. This in turn ends up powering devices like lights, refrigerators, microwaves, phones, the internet, you name it, the grid got it covered. But the grid didn't start this way, and with many things in life, there's always a beginning. Alright, story time, and there's nothing better to tell a story than to read it out loud. It was September 4th of 1882, and from what it looked like, it was another day in the Big Apple. People were walking around, carriages being drawn, and the hustle and bustle of New York City was in motion. And then, the clock hit 3 p.m. Something magical was about to happen. Something that will usher in a new era for humanity. Something bright. The motors at Edison's Pro Street Station started singing, and the concert began. So for anyone who doesn't know, it's called the dynamo. And basically it's like this power generation device that would generate DC power, which would go in conjunction with Edison's light bulb, which was DC powered. So this was a precursor to electric motors, AC induction motors. So it was a pretty cool thing. Let there be light, but not light from a candle, kerosene, or arcs, but from filament. Edison showed the world his most famed invention, the light bulb. So before the light bulb, the way humanity would get light was from the sun, of course, but also from candles, kerosene, which is like this oil, and something called arc lights. And arc lights are like this device. They're on these little tall poles, and at the very top, you got this glass enclosure. And inside the glass enclosure, there's like poles, and the way it would work was you got this gas inside that would get ionized from the electricity going through it, and it would make an arc. But the issue with arc lights is that they're very dangerous, and they're very hot, and they release UV, and you can't look at them, so they're not good for you. So the light bulb is way better than this, way better than the arc light. The soft yellow aura of electricity began spreading throughout Manhattan. First, it was a New York Times building, then 59 homes, and by next year, 513 homes. The darkness was tameable for electricity, and for Edison, the light bulb could be used in a scale such as in public utility. The light bulb could be a strong business proposition, and indeed, it was. Edison's investors included powerful people like J.P. Morgan, Vanderbilt, Spencer Trask. The world believed in Edison and his light bulb. It seemed like all of Edison's innovation in light bulb, electric motors, and electric transmission were all coming together on the same road to success. But all this initial success would soon face a roadblock. On May 1st of 1888, the United States, not the Supreme Court, the United States Patent Office began approving new patents. A basket-making apparatus, sheet metal shaper, brittle bit maker, and many others. And honestly, I don't know what any of these are. I just found them. And for anyone who's interested, you can go on Google Patents and you could search by a date and a year. Not just the way I did it. You can find, interesting patents like these, even though I don't know what they are. But one stuck out. One about an electric motor. Not ones like Edison's. No, this was powered by AC. The Edison's was DC, if you remember. This was Tesla's start. And no, not the automotive manufacturer, but Nikola Tesla, Edison's protege. And actually, Tesla, after he came to the United States, he worked for Tesla. Or he worked for Edison. And, he worked with arc lighting, but he didn't work for Edison for very long. I think it was probably like not even a year. And then eventually going to Westinghouse. But I'm actually going too far in the story. This new patent and other AC-based patents would be Edison's weakness and end his dreams of a direct current-based power grid. 15 days after receiving the patents, Tesla went out and lectured about his new slew of inventions in a presentation called A New System of Alternate Current Motors and Transformers. Transformers is the key word. From here, word got out and caught the attention of engineers from Westinghouse. And a month later, George Westinghouse buys Tesla's patents and hires Tesla as a consultant. Prior to buying Tesla's patents, Westinghouse already had been working on a transformer. Taking the knowledge of the transformer patents from Europe, Westinghouse and William Stanley perfected the transformer for use in AC power in 1886. And for anyone who's interested, William Stanley, he was very incremental in Westinghouse's beginning in his company. As I said before, he basically did a lot of the initial work with, transformers and getting that technology working. And the way they did it was they used a lot of, so before transformers got to the United States, transformers were really getting progress in Europe, like in Hungary and the United Kingdom, or the Austria-Hungary, it was Austria-Hungary at the time, and the British Empire. So they took some of that knowledge and they perfected upon it to get a transformer. So, and William Stanley was sort of incremental in doing that. And fun fact about William Stanley, he went on to invent the vacuum bottle, like the thermos bottles you get to keep the hot water or hot liquid, whatever's in the bottle, warm. So Stanley bottles, was his patent and his company. In that same year, Westinghouse set up shop and opened the first US-based AC power system in Buffalo, New York. By the time of buying Tesla's patents, Westinghouse had already built 60 plus AC power stations and was closing in on Edison. Now for this section, I wanted to highlight the difference between AC and DC. So AC stands for alternating current and DC stands for direct current. And DC, so the way DC works, so these are two different electric charge manipulation or standards. So the way DC works is that it's basically just a straight line. So you got current going one direction. Pretty easy to understand. And AC it's like a wave. It's like a sine wave. Current goes up positively and then goes down negative. So it changes direction. So it goes positive and negative. And AC was the platform that Westinghouse was pushing for, and DC was the platform that Edison was pushing for. But the issue with Edison's, and we'll get to this later, economics of scale and efficiency. So at this time, DC technology or DC power regulation technology wasn't really present. There wasn't really innovation in semiconductors yet. So, but a transformer was there for AC, and a transformer, what that allowed Westinghouse to do was to manipulate the power being generated from the power plants. So transformers allowed the power to be stepped up and transmitted across distances. But for Edison, for him to get power to his customers, he had to plant or make new power stations, and obviously this gets very expensive when you have power stations all over the place. So AC was just, in general, more scalable during this time. However, now, modern days, there's ways of manipulating DC to get the power you want to be comparable to AC.